All right, welcome everybody. A packed house as usual for today's data club. The meeting is called Day 1 Map Making in Leaflet, and we're going to start by going to the Columbia Data Club Observable Notebook page. No, not. Oh yeah, go ahead. Yeah. The Observable Notebook for Columbia Data Club page, which looks like this, or should look something similar to this. Mine maybe looks a little bit different because I'm logged in. One thing, this is public. Hopefully in a few days, I'll make a little video about it where I solve the problems that I had in the Day 1 data session from 2 weeks ago. So we had problems. If you are watching this on YouTube in the future and you go look for the video for this, you will not see the problems because I will have edited them all out and replaced them with a discussion of this notebook instead. But we'll be using this one, Day 1 Map Making with Leaflet. So Leaflet is a library. It's a JavaScript library for making maps on websites. So here is an example of one. It's a little bit big. And it uses the Google Maps style slippy map user experience, I guess we could call it. And you can scroll out with your mouse or your trackpad and scroll in to zoom in. And there's nothing, quote unquote, nothing here. There's obviously plenty here because you can see that it's New York City and you can see all this sort of stuff. But all of this information is just in a base layer, in a background layer. This is made up of a bunch of 256 by 256, I think that's right, pixel tiles that are loaded. If you move this really quickly, you'll sometimes see big squares because the image hasn't loaded yet. And when you zoom out, it's another whole set of 256 by 256. So the whole world is actually many, 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 many pictures because you have it increases exponentially. So at zoom level 1, it's 4 pictures. At zoom, or I think that's maybe zoom level. I don't know if it's related to the exponent or not, but you go from 4 to then 8 to 16, et cetera, et cetera. So this is something like zoom level 14 or 15. So whatever 2 to the 15th is, that's how many tiles you have at this zoom level. So I think that's a pretty big number. Yeah, 32,000 tiles. Assume like 10K a piece. So that's 32,000 times. So that's 320,000. So it's 320 megabytes. Just that one layer, and that's at zoom level 15, zoom level 17. So it's gigabytes and gigabytes are the tiles.
At zoom level 19 is the maximum that is allowed.
Yes. So this one goes all the way to 19. So this is what zoom level 19 looks like. I'm not 100% that zoom level 19 it maps to 2 to the 19th, but it maps to something around there, like probably maybe 2 to the 17th or something. But it's a lot. So as a result, making these kinds of maps, so generating these images is very is somewhat intensive, resource intensive, and serving them is resource intensive as well. So yeah, so one of the tips with Leaflet is if you know that the map is never going to go past certain boundaries, like you only ever want to show New York City, you set it so that when you get to the edge of New York City, it doesn't move anymore because that saves what has to get downloaded. Anyway, so Leaflet does not play super nicely with observable notebooks, and I will show how that is the case, which is why there's a second path today that doesn't involve observable but is more or less the same thing. And I will discuss that here. So the gear. This notebook has a bare bones HTML file. So if you click on the paperclip, you'll see there are two things here. There's a iPads directory CSV file that's in use. It's 4 megabytes. And then there's this teeny HTML file that's only 992 bytes. That HTML file is, can I get all of this to fit on the screen at once? Yes, it's this file. And this is more or less the minimum that you need to create a leaflet map. So I copied this, or I downloaded this file, and I just opened it up in a text editor in VS Code. And so it looks like this. And then I also opened it up in a browser, and I commented out all of the code. There's a little extra code here for later. So with everything commented out, and I open this file and I just load it and reload it, we can see that when we look at the elements, it looks almost identical. I mean, it's just collapsed, but it has the leaflet style sheet, which is here. And then it loads the leaflet JavaScript once we're inside the body, which is here. And then we have to have something that acts as the container for the map. And that container in this case is a div with an ID of map. And then we also have to style, we have to do one CSS, there's one CSS rule that's required, is that the container has to have a specified height. So here, this CSS, if you aren't a pro at reading it, the hashtag means the entity with the ID of map, and the HTML tag have a height of 100 VH and a width of 100 VW. VH is viewport height, and VW is viewport width, which is why when I highlight over the div map, the entirety of the screen right above lights up in blue, because that's the whole map. Even though it's empty, there's a div there that stretches to the entire size of the window. And you can see it even says there, it's really tiny. It says 960 by 156. And if I stretch this down a little bit, it's 960 by 314. So that's the size. So you have to have that. If you don't set a height, it will not draw the map. It's a rule. And then after that, we have, in my thing it says script type module. It doesn't say that over here because you don't actually have to have it set as a module. Writing type module is a new thing in browsers only as of the last couple of years or so. I have not really run into it because I tend not to write raw HTML much anymore, and definitely I don't put JavaScript into HTML files, but to keep this concise and in one file, I did that here, so you would have to have type module, as you'll see later on. But this by itself works fine. So what happens here is I created a constant called center coordinates that has two numbers in it. These are coordinates, a latitude and a longitude. Does anybody want to guess what this latitude and longitude is?
Colombia.
Yes, Colombia. It's, yeah. So many of these examples are New York City, whether the person is based in New York City or not, that it's a little bit touching that the official leaflet documentation is centered around London. So at some point, the New York bias left. Anyway, so that's all captured here in this scripting. So we can see this is all commented out. And then if I uncomment this, and then I will mostly close this thing, and then I think I have to save here, and then I reload here, we now see a less blank map, in the sense that earlier we had nothing. It was literally blank HTML. whereas now we have this gray box here. And it's important to, it's important to show this, I think. So when we had it commented out, this is just an empty div. There's nothing here. It's just the open tag and the close tag. There's no triangle that I can click on to make this div get bigger. When I uncomment this one line of code and save and reload here, all of a sudden this div has a ton of stuff inside of it. So it still has the ID of map, but now it has all of these classes. It has a tab index. It has some inline styling, and then it has all this stuff in here. So I want to talk about this one line of code, which is the third, or comes down here in the JavaScript. So to recap, we have one, loading the Leaflet CSS, the style sheet, that styles how the various panes work and how the default pop-up looks and these sorts of things. We have to load in the Leaflet GS in a script tag inside the body. It doesn't have to be in the body, but that's the convention, is to put your JavaScript at the bottom of your page. And then we have to style the target container with an explicit height, like I said, and I set it to 100 VH. Then the JavaScript. When you load in the Leaflet, when you load in that line of Leaflet, it creates this global variable L. This is something that I don't think a lot of, it's not the best practice anymore to fill the global namespace with things, but Leaflet's got a little bit of some old-fashioned character that, so it does that. So L is all of Leaflet, and it's a little bit like the PD in Pandas. Like, there are certain methods that are L dot that you have to use. Like in Pandas, you do pd.dataframe to create a new data frame. In Leaflet, you do L.map to create a new map. So I can go back to the page and show this, this specific line has L.map is initialize a map, and then the parameter is the ID of the container.
Oh, no.
Now it's not, it doesn't have a hashtag. Even though that's kind of normal, it doesn't use the HTML or the CSS selector for something with the ID of map. It's just the string by itself. So that's a little bit of a weird thing, but you do it once and then you know. And then it creates a map object that has a method called setView, where you can set the view to the center coordinates and set the default zoom level to 17. So even though this map is empty, quote unquote empty, this is actually Columbia University. The center of this map currently is the coordinates for Columbia University. So then the last thing we have to do here is load the tile layer, and I'll go here to talk about that. So this is what I cover here, and then we can look at various tiles that are available. This centers around France, so let me move it over to New York City so we can look at these tiles. So this is the OpenStreetMap, the default OpenStreetMap one, and you can just click and look at the different options here. Some of these you have to pay for. Some are localized, so this OpenStreetMap.ch one I think only has most of Switzerland in it. And then if you keep zooming around, they get kind of fun. This is bringing me back to being in grade school, and the maps on the walls in the classrooms, they all looked like this. And which means I can scroll over to Holland and look at all the dark green and be like, how do those people live underwater? Like I did when I was a kid. Yeah, all this dark green. Anyway, so there are, and some of these are more useful than others, and some of them get kind of wild, like this one. So it's a space for creativity.
What is this for? Which, this one? Like,
Just for fun, if you want to make a heavy metal map.
okay.
And I mean, it's
Other map.
it's
Oh, well, heavy method, yeah.
yeah, it's a great proof of concept because it shows how flexible creating these tiles. So the way that these tiles are created is you download the data from OpenStreetMap, which is enormous. Like it will fill a hard drive. And then you create a style, like a theme, that says, you know, these types of text, this type of text should look like this type of thing should look like this, for all of the different points of interest and all the different things like that. So it's a extremely complex I guess, ontology of styles. And you can even set fonts and stuff. So that's why we get this heavy metal look. So we are using the basic OpenStreetMap one. I think this heavy metal one, I think you have to pay to use it. Yeah, you have to use an API key. So that's why I never use it. Otherwise, I would have many demos using the spinal map, which is also a very funny name for this theme. Spinal map.
Is the watercolor one still free, or is it?
Yeah, Stamen's watercolor is, I think, still free. Oh, but Stamen is now part of Stadia, which, yeah, there's nothing here about. So what you get here on this web page is it actually shows, you can just literally copy this and paste it into your document and use it as so actually I'll do that. I can just go over here and I will comment this back out, and then I'll just paste this in, and then I will do Stadia Stamen watercolor add to map, and that should work. Nope, you have to pay.
Okay.
So I don't know exactly how that information is, how you feed that information in, but yeah, you have to pay now. This used to be free. Maybe it's true for all of the Stamen.
What is Stadia?
Oh, Stadia is a company.
Okay.
StadiaMaps.com. Stamen is/was a design company that made, well, I don't know. They were a web mapping company maybe, but what I know them for mostly is these base maps. And these are very nice base maps. The Thunder Forest ones are also not free, but they're a little bit silly. They're the ones that make but they can, it's very, very broad. Oh, I've never seen this one before. It's very cute. And some of these are free to use, but not from free entities. So one example is the Esri World Topo Map. You don't need to use a API key, I don't think, well, how about I actually try it?
Yeah, they used to be free.
Yeah. So it's a very clean, handsome base map with this level of data is, because it's New York City, don't expect building by building outlines everywhere in the world. The Esri, the world imagery, so this is satellite, the world terrain, this one, oh, it does still work. This one I like using because it just has the terrain, so it has no political, or this set of Esri maps I like. I feel like this is sort of like the basic Esri color scheme.
Yeah.
And I like this world physical one because it looks kind of like what the world looks like in my head, but with no political markings at all. So I use this when I make maps that are radically take up a very broad swath of history. This is a very good base map for that. So if you have something where you have places from the Roman Empire as well as places from today, something like this is nice because it forces you to remember that borders change and they're calling them a construct sounds like they don't exist, but obviously they exist, but that they are things that have to be engaged with differently at different times. Okay, so there are a bunch of these, and they keep adding more and more, but we'll stick to the regular OpenStreetMap one, so I will delete or actually I'll keep it here. Why not? I'll keep this Esri one, but in the notebook, we use the OpenStreetMap one. So here's Columbia. Okay. I've spent a lot of time on this, but that's great. It's fun for me, and hopefully for you. So the tile layer is created by l.tilelayer, and you feed in a string that gives sort of the template for how it looks up the images. You can see that it's Z is the zoom level, then there's an X and a Y to know how many pictures over and how many pictures down. In PNG, you set a max zoom and you set an attribution where you can add copyright information that shows up on the map. It shows up right here. This is the attribution for the Esri map. And then you have to have this add to map at the end. This is sort of, Leaflet lets you create objects, but then you have to explicitly put them on the map. And this is helpful because it lets you do things like make whether something shows up or not part of the user experience. So there can be toggles and whatever, because it keeps in memory a sense of all the markers and everything, even if it doesn't show them at a specific time. Okay, so then we move to the data. This is the tricky part. This is the actually tricky part. So because JavaScript is designed to run in the browser, it doesn't have the sort of file handling capabilities that we expect from something like Python. So there isn't a built-in CSV parser, for example, in JavaScript, at least that I know of, unlike in Python, where you just do, I don't even know if you need to do import CSV, but it's definitely part of the base Python. In JavaScript, you get around these limitations by fetching documents from the internet. You can get documents from the internet. You cannot get documents from the local system. So what this means is, even though this HTML file here is on my computer, I can't do something like open file and give it the name of a file that's in the same folder as this HTML. It will not work. JavaScript will not look at your local disk under normal circumstances. In Node, this is possible, but we're not dealing with Node. So what ends up happening is I have to do things like put the data files, nope, that's me. I want to go to the data club. Columbia Data Club. I go to Columbia Data Club, and we have a data repository here that's still kind of small, but I got this education data. I actually had to use this data set for a homework assignment that's due in a few hours. So this is education data for post-secondary higher education, read colleges and universities in the United States in 2021. It's huge. It's 3 megabytes or something like that. I mean, it's bigger than I would expect. And It has something like 90 some odd columns of data, and it is very well described here at the education data portal that has, if I go to directory, there we go. So I did an API call to grab the 2021 data, which is the most recent one currently available. Actually, I could have done it. Ooh, this is a very old way of doing this. I'm not going to make fun of anybody. And so it has a bunch of information. Anyway, so I created a CSV out of that, and I uploaded it to here. So that's this file here, iPads directory. So if you're playing along at home and you have this notebook open, you can download it right here. However, it is also, where is that GitHub? It is also here. And the reason it is here is because if I click on this and then I do view raw, I get a URL to the file. So this is the CSV. And then I can copy that and paste it in to a fetch API to grab it from the internet. So I can't have the file next to my file on the same computer, but I can put it up on the internet via GitHub and then grab it from the internet. So in Observable makes this easy because they just do this way. So what I did here is just, that's it, is I clicked on, it used to have an icon like this, arrow to the notebook, and it put this in there. So here's the data. We can see there are 6,000 rows, and I've greatly reduced the number of columns that are shown, but there are many, there are 95 of them or something like that. I'm only showing 7. And what we can do then is we can iterate over this data file to put dots on our map because it has a longitude column and a latitude column. So here's the big caveat of using Leaflet with Observable is one of the things that I'm very excited about when it comes to Observable is its reactivity, where you can make a change in one section to one block, and that change bubbles through the entire notebook. Unfortunately, there's no way to do that. I can't access or control the map at the top of this notebook from anywhere else inside the notebook except the block that defines and initializes the map itself. In that block, I can refer to other blocks, but I can't here arbitrarily write something that says, oh, and map do this now. So instead, what I have to do is I have to copy this, and I think I'll copy it. And I'll explain what happens here. I create markers, which is a layer group, and then I iterate over the CSV file, which now exists as this data file. And for every row, I create a marker. So l.layerGroup, layerGroup is a type of object in Leaflet, and a marker is a type of object in Leaflet. So marker is equal to l.marker, row.longitude, row.latitude I set, and then I bind the pop-up with row.instName, which is the institution's name. And then I add the marker that I just defined, const marker. I add this marker to the markers layer. So all of the markers are in a layer. The Leaflet is made of a bunch of layers stacked on top of each other. And then I add the whole layer to the map. I don't have to do it this way. I could add each marker by itself, but this strikes me as a little bit cleaner for some reason. And then I can scoot back up to here and open this up, and we can see how I did this here. So I had to create a container, a div, and that then I initialized the map in that container. So this is a very odd way of doing this, but it works. And then here is that code that I had down earlier, so I have to uncomment it. And then I save, and now it's going to crash because it's too much data. Or it won't crash, or it takes a bunch of time. But now we can see it put a marker here at Columbia, and if I click on it, it says Columbia University in the city of New York. So there we go. That's how we took a CSV with a bunch of latitudes and longitudes and a name and turned it into a bunch of markers. So what I will do so that this goes a little bit more quickly is I will first filter this. Filter, row. I don't need to do that. So row. Oh, I don't have this. Give me a second. The state is definitely here. It's just not highlighted here. Columns, state upper. So state upper. So I want only NY as a state upper, as the state abbreviation. That may be state upper equals NY. And now it loads much more quickly because it's only loading the universities for New York. So in slightly less quickly. Initially, it iterates over the entire, all 6,000 rows, and it creates a marker for every row. That is a, Leaflet doesn't like to have to make thousands of markers at once or place them on, it just slows things down. So for the purposes of this demo, before I build all those markers, I filter this data set and only include things that have a state abbreviation of NY. So now if I zoom out here, we should see a bunch of these little teardrop, inverted teardrops in New York State, but nothing in Jersey or Connecticut or anywhere else, and that is the case. So this is the distribution of post-secondary institutions of higher learning, or whatever you want to call them, in New York State, which is probably very correlated with a population density map of New York. One of the things that we did in the homework was we plotted this out and to see the universities in across America, and it just looks like a population density map, which is not surprising. Okay, so let me just reload this, because that may be a quicker way of getting back to Columbia. So we can even see what kinds of institutions are near Columbia. Bank Street College of Education, news to me. Barnard, we know. The Theological Seminary, we know. The Union Theological Seminary, we know. The Jewish Theological Seminary, we know. This, I think, is going to be the Manhattan School of Music. This is going to be Teachers College. So maybe I know most of these institutions after all. I don't, yeah. Okay, so that is basically the underlying, the meat of what we've got going on here. I realize I thought I was taking forever, but I rather sped through the second part of it, because ultimately these are the basics, is that you get this map object that you then create other objects that you add to the map. And a lot of it is explained very well in the Leaflet demos. So if you go to the Leaflet page, you have demos here that tell you how to do very specific things. You can draw shapes. You can use circles instead of regular markers. You can make custom icons. I've made use of that in the past. You can use GeoJSON, which I think I've mentioned before, which is a rather friendly way of making geographical data sets for use on the web. There are ways to make things interactive in many different ways, and you can even make non-geographical maps, which is to say maps of things that aren't the world. So this can be helpful if you have a map of a place that doesn't exist, or if you have a map of you have a map that you don't want to stretch and warp so that it fits on the projection that Leaflet uses by default. So you just say, forget it, I don't care about the background of OpenStreetMap, I just want my picture to be the map. That's a whole other thing in and of itself because making the tiles is rather difficult, but it is possible. And these tutorials are pretty nice. Oh, that's one thing I wanted to do. This caveat I already explained, that the reactivity doesn't work like we would hope it would, which is why I have this second train here of doing this. So let me explain how to get the dots on here because it's a little bit different. So like I said, in JavaScript you can't access the file, local file. So what I have here is I load D3, which is a library probably more known for making visualizations, but it has a handful of very, very helpful helper type methods and so on. I thought I had it open here, but I don't. And among them is, it has a whole module called D3 fetch that includes the method CSV, where you paste in a URL of a CSV file somewhere on the internet, and it downloads it and parses it and makes it available to you as an array of plain old JavaScript objects. I think that's correct. So we load D3 by pasting in this script to load D3 at 7, version 7. And this creates a D3 global variable that populates the global namespace, but this is the old-fashioned way of doing things. And then if I do this const data equals await d3.csv, you can see all of this. This is the URL to the CSV file. What this does is it loads the CSV and makes the variable data out of it. Now this await is why you have to have script type equals module at the top. Await is the way, the await keyword is how JavaScript is one of the ways JavaScript handles asynchronous stuff. So you have to add, because you're fetching something from the, so JavaScript will just keep running things. But if you're fetching something from the internet, you want to wait until it's done. So before you execute any more code, especially if you are relying on that code later on because it will crash. So there's the async await keywords in JavaScript where you can write an async function and then you can do things to make it so that you await it to grab things from the internet and not do stuff until then. That asyncness, and I don't completely understand how this works, but that, oh, it's telling me right here. But that asyncness is made available when you do type equals module. So what this means is define a variable called data and wait to assign to it the result of d3.csv grabbing this page. So you can't really see it wait because it loads it very quickly, but like a little thing ticks here. If I did a print something here and print something here, there would be a brief little pause while it's waiting for this to load. Once data is available, then everything is identical to the observable way, except instead of, I didn't call it iPad's directory, I just called it data. So data map, and then if I save this and then hit refresh here, you see how it took a second? Let me do that again. It takes a second, things are faded out, and then because it's loading the points. I don't know if there's a way to, this grayness is something I think that's a little bit new to me. So I don't know if this is intentionally being done to say it's waiting for something or if this is a weird hiccup, but it's kind of cool because you can see it's not responsive, but you have to anticipate it, otherwise you'll think it's broken. So these are just things to think about, and this is the same thing. Okay, so
I think before it used to just be gray or empty or white, so this is nice. This is better.
Yes, if it, and you can see it's still pokey. Yeah, so before we saw that here, so if I zoom out, you can see it's getting pokey loading the tiles because it has to draw all of these teardrops. It may be faster if we use circle markers instead. Feels faster. Anyone want to guess why it's faster with the circle markers?
Vectors as opposed to.
Yeah. The circle markers, these are SVG vectors, as opposed to the little teardrop is an image, so it has to load the image every single time, whereas the vector, I mean, each of these is fed in, but it's a vector of draw a circle or something. It's really small. The amount of code it takes to describe the circle is much, much, much smaller than the amount of code it takes to describe the little teardrop. And so I think that that's why it's springier. I almost always use circle markers, not for that reason. I think they're prettier, but it feels nice in an introduction to Leaflet to use its default marker. But we can also see just how many institutions of higher education there are in Lower Manhattan, which is a complete surprise to me, but if I spent a minute thinking about it, maybe it wouldn't be. But let me then also talk about the pop-up, the label. Leaflet also lets you make tooltips, which are the same thing, except they show up when you hover. Here you have to click, and if you click away, it disappears. Now, this is one of the best parts about Leaflet, is because this pop-up is just HTML. So if here currently I have bind pop-up row.inst name. This is tricky to do in observable for reasons that may be obvious in a little bit. But I can do this, I can change this into a JavaScript template literal. Yeah, template literal, which is just surrounded by backticks and then $ bracket brace and close brace here. And if I save and I reload, everything works the same. But now I can do something like add just HTML. Let's put this, surround this in a paragraph tag. And now I get university and I get styling in here. And then I will do what I always love to do, which is go to Imager and try to find images that are okay to use in workshops. These are a little bit more risque than I remember, or than I would have expected. This one looks safe. So a picture of some draping. Copy image address. I'm going to skip making an alt tag and all that because I don't even know what this is. Something about someone is clearing things up on their page, on their phone, and it just loads the picture. So any kind of HTML, oh, it goes on. Any kind of HTML you want to put into your pop-up, you can. And obviously this picture loads with every single pop-up, which is kind of silly. But your data file can have a separate column or separate row, no, separate column for an image URL. So you can have it be that every single pop-up every single dot that you click on, the pop-up loads a different picture and a bunch of HTML with any amount of arbitrary JavaScript in it. So it even is a little box that you can page through things for multiple pages of content even just within that one little pop-up. And that's amazing that they did it that way. And there are ways to change the CSS in Leaflet so that you can guarantee that the pop-up will never get bigger than a certain size or never get taller than a certain size. These things are helpful. You can change that sort of generic rounded corner look. You can the shadow effect that might not be completely visible, you can change that. You can change where this little notch shows up, all this sort of stuff, what the close button looks like. All of this stuff is not difficult to change. It's all, at least to me, very clearly implemented. And that could be partly from my having used Leaflet for so many years, but it strikes me as very clearly designed. And the idea of doing things this way is great. The markers are the same thing. So here I'm using the circle marker that's just an SVG circle. I think that's right. It's definitely SVG. I don't know if it's an actual circle object. It may be a path. But you can also have it create an HTML div as the marker. So you can put in custom SVG inside that div, and you can have fast loading icons that are SVG that are custom. So whatever you want. So I did that. I had to make a map for a conference that had, and I wanted to make different icons for where the restaurants were and where the bars were or whatever it was. And it's just very straightforward. It's very clear. I don't think that there's a tutorial about it. Oh, you end up doing it here, markers with custom icons, but I don't think that they explain how to do it with SVG. No, they don't. So it's in the documentation. It's called div icon. So it's you create this object div icon. You give it a class so you can style it in CSS, and then it's just HTML. It just creates an HTML div that you can fill however you want. So it's really cool, and the pop-ups are really cool that way. The tooltips I think are not as flexible, but okay. So I think that's about it. I didn't have any homework or any group assignments because of how badly they went last time, but that's basically it. Oh, one other thing that I did not cover, because it's a little bit tricky to show in observable, is handling the map state, which is to say, let me zoom in a little bit on this. There are many, many methods that map dot something. So we create that map object that's a leaflet map, and then we can do map dot set view. So for example, we use this when we initialize the map. We add l.map little thing dot set view, et cetera, et cetera. And then there are a couple things here like set zoom, zoom in, but what should be notable is that these sorts of things, pan to, pan by, fly to, fly by, set max bounds, set min zoom, these are all things that you can do with interactivity. So you can do things like make click handlers that say when a user clicks in a certain place, it does something like zooms to another part of the world, except something more useful than that. And it can make for the fly to zooms out, flies over, and zooms back into another place. So it has this kind of out and in effect that you can use to tell stories, because you can set it up so that the JavaScript works like a little bit of time elapses and then something happens and then things move around. and it's surprisingly not complicated, at least to me.
So sorry, this is
yes.
For whenever you open the website, like the user opens a website, like the map is moving with like automatically because we code it like that.
Yes, you can. What I'm saying is that you can program it so that it either responds to handlers or it does it automatically. Actually, I have an example of this. Let me see if I can remember how to get to it. Let's guess.
And after these kind of commands to be executed, like the user can interact with the map, or
Yes. So this is a project I made. There's a ton of D3 in this, but the maps. I mean, you can see it says Leaflet right here. So if I press play, it starts moving around. So these dots are actually made in D3, like that little explosion effect is a D3 effect. But these maps, this map will, I don't remember if this map moves around, but you can see that this map is moving around. Like this is all just, I didn't say, and then move to Ireland, and then move somewhere else, and then move somewhere else. I just said, created a method that said, or that used the fly to method in the map that said, then fly to this point, then fly to this point. Like it's just iterating over these things. So it's going through this text. This is from the novel Ulysses that has a bunch of places mentioned in it. And it is showing, as it's going through the text, it's playing the little dots where these things happen. So again, like I said, I don't think that this zooms in any, but this flies around whenever things that don't happen in Dublin are mentioned, this changes. So this is just an example of some rather maybe not straightforward, but not terribly difficult coding. And then things get a little bit chaotic after a little bit of time. So what this is showing is it's presenting the events of this chapter in chronological order, but you can see down here it's hopping around the text because the text is presented not in chronological order. The events in the text are mixed up. And yeah, so this is a combination of D3 and Leaflet, but like what Leaflet is doing here is it's handling what's going on here with the map changing, zooming, hopping around, doing all this sort of stuff. And that's it. So I'm going to need to see that whole show, but that is how, or that covers the methods for modifying the map state. So I think that is a super helpful and useful. And then also the Leaflet map is very attuned to many events. Let me see if I can find where it is. Map state options, events. So you can have things happen when layers are added or removed. You can trigger things, like you can, and anything can happen whenever anything else happens, basically. So you can, the number of events here is huge. So you can do things that happen when someone starts zooming. In one project I created it where the base map is different depending on what zoom level you're at. So if you zoom out, it's just the plain world with no political boundaries. But if you zoom in at some point, it switches from that to the OpenStreetMap. So you can see if the place is important enough that you need street detail, then you see it. But zoomed out, you see the whole world with no streets, no place names, no nothing. So these are the sorts of things where like zoom start at the end, or zoom end. At the end of the zoom, check what the zoom level is. If the zoom level is greater than some number, remove the current tile layer and add this tile layer instead, or show or hide or whatever it is. So there's like, this documentation is, in my opinion, also extremely clearly described, and it's all on one page, so you can just like search to find things. And yeah, I should probably stop there because it's so possible to do so many things. You can create your own control buttons that do different things. And yeah, I mean, you could conceivably build an entire GIS app mostly with just Leaflet. You could probably, like, because so much state control is there. You can't reproject. You can't do that sort of stuff that some people might think is like a requirement of any kind of GIS app, but you can do a ton. Oh, one last thing is to find latitudes and longitudes. I wanted to mention this website, latlong.net, where you can type in a place. I tried Lehman Library, which is where we are. Oh, come on, be nice. I'm not a bot. I don't know what this is. It says Lehman Library, but I don't even know. Pennsylvania? Lehman, Pennsylvania? Sure, who knows? Bushkill. Maybe it actually is a library called Lehman. No idea. Dutch Reformed Church, so this is Amish country. Who knows? All right. Any questions?
Just that in order to follow you, we couldn't see in the observable, in the attached files, we couldn't see the HTML, like the second.
Oh, yes. So yeah, you can't click on this to actually see it. You would have to click on it just to download it and then
No,
open.
we don't have. Do you see it? Because I only see one file, like the.
Oh, it may be because I'm the sort of so you can only see this one because it's in use. This one maybe doesn't work, but that's okay. This HTML file is exactly the same thing as this. So you can just copy this and paste it into a file that you call like blah blah blah.html, and then that's that.
Okay. Because I thought that one had more code than.
Oh,
like
eventually.
Smaller.
Yes, eventually I did put more code in here that has the D3 stuff, et cetera, but those are the goodies you get for coming here, as opposed to I may put this up on the GitHub, but I may just attach it to the bottom of the notebook.
Okay.
I'll have to think about it a little bit, or not.
It'd be great
Yeah.
to see it.
Okay. Yeah. Well, all right. Fine. I'll just attach it to the bottom of the notebook.
Thank you.
So it'll be an appendix, and it's tempting to do this HTML thing, but that'll break things. So instead I will do tick, 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 HTML. It will complain about this, so I have to do this way.
But it's okay if it complains, right? Because the point of this is to copy it out, right?
No, observable will literally complain.
Oh, okay.
Because, so actually I meant to show this or spend a little bit of time on this. So just give me 1 second. The final HTML file. Okay. So yeah, so this includes all the D3 stuff and downloads the data from GitHub, and then uses the different tile thing, uses the ArcGIS the world topo map, and has the slightly more advanced pop-up. But what I wanted to show was all the way up here. Oh, it won't complain there. Sorry, I'll explain. This is maybe a little bit niche, but I'll explain what's going on here, because I think it's important also for me to say it out loud so that I remember it for future reference too. So let me put this back in here, like this. Oh, no, it does complain, even here. Okay. So the issue is that you can put inline JavaScript in an observable notebook based on things that you do elsewhere. So for example, let's create a just foo equals bar. And then I'll run that. And then I'll create a markdown file and say, what is foo? Foo is bar. And then, oh. So it knows, even though this is a markdown cell, I can still put in arbitrary JavaScript. So I can do, even though it's markdown, I can do, to math pow 2 to the 17th. And then close this, and then we get what 2 to the 17th is. If I knew this, I'd completely forgotten it. And the reason it came up was because, I'll delete these just because they will seem extremely opaque to future users of this notebook. Because it came up, or I noticed this because here, so this is regular JavaScript, and you see that it refers to something called width. I don't define width anywhere. Width is let's call it a global variable in observable that refers to the width of the cell. So I can set the width to that many pixels, and I set the height to 0.6 of the width. So I could change that to 0.4 and make a shorter map. Just maybe a little bit easier to read. And what happened was here I did just like what I did in the HTML file, which was I typed out, come on, type correctly. I typed this, and we get, hey, where's the error? Oh, it doesn't error here. It works fine here. It errored here. Here's where we get the error. Because if I type in the exact same thing, so here it's complaining about spelling, but we don't care about that. But I type in the exact same thing here, and now it crashes. And if we look at the crash, it says row is not defined. Because even though this is a markdown thing, and even though this is fenced off as code in markdown, it is still trying to execute the JavaScript here because of the $ brace, which is how you do a template literal, which implies that every markdown block and probably every HTML block, like when you pick if it's going to be JavaScript, markdown, or HTML, these are effectively template literals. So you can invoke blocks that you've defined elsewhere. Super powerful if you think about it for a little bit and think about ways to use it, but is extremely unexpected behavior to me because Jupyter doesn't do this. Our studio does do this. There are ways to do inline R code in your markdown section of an R markdown document. But yeah, just unexpected. Because I thought I was safe by fencing this off in code. No, it works fine. All right. Thanks, everybody. Jeremiah, go ahead and hit stop recording.